Hi friends, let's continue our work on branch and bound. Now let's see how 15 puzzle can be solved using branch and bound. And 15 puzzle is one which has got a 4 by 4 grid wherein there will be 15 pieces with numbers 1 to 15, and the 16th place is vacant. So these can be moved, the pieces can be moved up, down, left, right, so that the empty space is occupied by these coins, and the initial state of the board can be anything, and the aim is to arrange them in order so that the order will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, and the last place is empty. So that's the aim, and let's use least cost branch and bounce method. And here we begin with some random state as shown here. So the place of 7 is empty, and the place of 11 is occupied by 7, place of 12 is occupied by 11, and place of 12 is occupied by 11, and a blank is occupied by 12. So in all, if you just look at it, this problem can be simply solved by moving 7 up, moving 11 left, and pulling 12 up, then the whole thing would be solved. So what we are trying to say is we are using our intelligence and using heuristic way we are trying to solve this, but definitely this way I cannot write an algorithm, and it's difficult for me to do. So we can take up some logical steps. So we can look all possible things. So first branch, and then instead of going into infinite possibilities, the total number of possibilities are 16 factorial, and that's something 20 to the 20 into 10 to the power 12 possibilities are there, which is definitely impossible to work on. So we need some intelligent way of solving this, and that intelligent way of solving this would be a branch and bound method. So branch it and then bound the things which are not going to help us in finding the solution. So that's a simple way of working. Okay, that's our initial state. Now we have something called cost function, and that cost function is going to find overall error in the board. So one simple cost function would be identify the number of tiles which are there in the wrong place. So 1 is in right place, 2 is in right place, 3 is in right place, 4 is in right place, 5 is in right place, 6 is in right place. There has to be 7 here. 8 is in right place, 9 is in right place, 10 is in right place. 7 should have been here, but it is here, so that is wrong place. Then there has to be 11, but 11 is here, so that's a wrong place. Then we have this should be 12, then 13 okay, 14 okay, 15 okay, so this has to be a blank. So there are totally 3 mistakes in this. Now what we can do is we can move this blank space up, left, down, right, or down, and after doing that we get a different configuration. So if we move the blank space up, that means the tile 3 is moved down, or if you move blank space to the right, that means tile 8 is moved to the left, or if you move the blank space to the down, which means that 7 goes up, and if you want the blank space to be moved to the left, that means this 6 tile has to be moved to the right. So if it is up, this is the situation. If it is right, this is situation. If the blank space moved down, this is situation. And blank space is moved left, this is situation. Okay, now let's see how many mistakes are there. So 1 is in right place, 2 is in right place, this has to be 3, 4, 5, 6. So there has to be error in this 3. 8 is in right place, 9 is in right place, 10 is in right place, 7 is in wrong place, 11 is in wrong place, 13, 14, 15 are in right place. So that's in right place. So 1, 2, 3 and 4. So by changing this, instead of 3 mistakes, we have 4 mistakes. That means we are going away from the solution. Okay, let's see what this one says. 1 is right place, 2 is right place, 3 is right place, 4 is right place, 5 is right place, 6 is right place. There was supposed to be 7 here, so that is wrong. 8 here, 9, 10, this has to be 11, this has to be 12, 13, 14, 15 right, this has to be blank. So 1, 2, 3, 4, so errors 4. Now looking at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah, all of them are in right place. There has to be 11 here. This was supposed to be 12. 13, 14, 15 are in right place. And 12 was supposed to be upside. So in all, there are 2 errors here. 1, 2, 3, 4, right place. 5 is right place. 6 is in wrong place. 8 is right place. 9, 10 right place. 7 is wrong place. 11 is wrong place. 13, 14, 15 right place. 12 is in wrong place. So 1, 2, 3, 4 mistakes. So we are looking for least cost. Therefore, the cost of this is 4, cost of this is 4, cost of this is 2, cost of this is 4. So this has got a minimum error. So we can continue with this. So this situation we got after moving the blank space down. Therefore, we cannot move this blank space up. Otherwise, we reach back to this original place. So it can get us into infinite loops. Therefore, make sure that this is not moved up. Then other 3, you can move blank space to the right. You can move blank space to the down. You can move blank space to the left. 3 options are there. So if blank space is moved to the right, then 11 comes here. If blank space is moved down, then 15 comes here. And if the blank space moved to the left, then 10 comes here. These are the 3 options we have. Now let's count how many mistakes are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All are in place. Done. 13, 14, 15 are also in place. So only 12 is in the wrong place. So we have a 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15 in wrong place, 11 in wrong place, 13, 14, okay, 12 is in wrong place. So there are 3 mistakes in this. Now looking at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 should be here, it is here, so that is wrong. 11 should have been here, it is here, that is wrong. Then 12 is also in the wrong place. So we have 3 errors. So least cost, so minimum errors is with this. So continue. Now the blank space is on the edge. So it can go to the left, up or down. 3 options. Left is not possible because from where we have come. Therefore we are left with only up and down. So if you move the blank space up, then 8 comes down. And if you move blank space down, then 12 moves up. So if you take this, 1, 2, 3, 4, 5, 6, 7 are in place. Then 9, 10, 11 are in place. 8 is in wrong place. 13, 14, 15 are in place. 12 is in wrong place. So totally 2 mistakes. And looking at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Yeah, wonderful. We have reached the solution. So we have reached our goal. So congratulations. So we have done this in a very finite number of steps. We can start from anywhere, and then from there you move stepwise all the possible moves take up, then find the cost, and then look for which is the best possible thing to continue, the best configuration to continue. That's the least cost. So first time it was 4, 4, 2, 4. So 2 was the best one. So we continued from this, then extended it. Then we found that 1, 3, and 3. Therefore, we found this is the best option. Then we extended this, and then we found that the error in this is 0. So when error is 0, that means we have reached the goal state. So in all, instead of 10 to the power 12 possibles, we have done with 1, 2, 3, 4, 5, 6, 7, 8, 9, hardly 9 combinations we tried and reached the goal. So that's the power of branch and bound, because we extended only the one which gives us confidence that we can reach the solution earlier. So from here also we may reach the solution, but definitely not in the earliest way. So we just bound this, bound this, bound this. So no more extension required from here. So only one thing is allowed to expand. Then after that we bounded this one, we bound this one. Therefore we could allow only one to expand, and with that we could reach the goal state. So that's the power of branch and bound. So thanks for watching this.